Yes, guys. So we are doing now question number 12. Okay. 11th question we did as the question number 4th. Okay. The two questions are same, and we have applied both the methods. First method we applied in case of question number 4th. In the same question we have applied the second method also. The shape of the curves are the same. Shape of the curves in 11th question, sorry, 11th and 4th question are same. They are having a similar type of values. X equal to the same thing, y equal to same thing. Question number 4th and question number 11, they are similar, they are same, but for them we have applied two different methods. Okay, first method we applied there in question number 4th, second 11th question we did by second method. So second method, as I described, that the second method is when we are not successful or easily not transforming the parameter given their parameter t or theta or the third variable into the Cartesian form. We are not able to eliminate the parameter theta, t or phi, okay, into Cartesian coordinates. Then we apply the second method. For the second method I described in the beginning. Let me again clarify. In 10th question, 11th question also we have applied the same second method. Second method is this: we find dy dx, differentiation of the two parametric equations, okay, in x and y, and then we differentiate them with respect to the parameter dx dt we find out, dy dt we find out, then dy dx we calculate. Dy dx, as I told you, that is equal to d by upon dt, dy dt divided by dx by dt, dx dt. Okay, so this will give us the value of dy dx. Now for different values of parameter, suppose t is the parameter, then we substitute some different values in. If the dy dx value is in terms of angles like tangent theta, y, okay, cos theta or whatever, or if it is in tangent theta, cot theta, secant theta, and any trigonometrical value, then we put the values of t in terms of angles. Okay, that is the logic here. That the main logic here. Okay, to think about that what value t is to be substituted. The value for t we have to substitute by watching the value of dy dx, by taking into consideration the value of dy dx. Okay, so from there we can just assume that what value we have to substitute. Okay, then we find out the value of constant, so the Cartesian coordinates x and y, and the d by dx, the derivative d by dx. So these three values, these values of three variables or three, two variables and one derivative, we plot them the curve for the graph for the given points. Okay, so we find a table for different values of t, what is the value of x, what is the value of y, and what is the value of dy dx, and after that we plot the graph. So the graph given there will trace the curve. Let me take the 12th question. In this case, the second method, okay, by finding dy dx, okay, will be applied, because in all the 5 questions I have taken, 10th, 11th, 12th, 36th question, 13, 15, 14. In this, as I have seen that the second method is applied, then it is easier to solve. Okay, so in case of these questions, I will apply the second method. So okay, so let me take the question number 12 here. I have written down already. X equal to here a t minus sin t, y equal to a into 1 minus cos t. So what we have to find out? So we first apply. We have to apply here the second method. Solution. Applying the second method. Applying second method. That is finding the value of d by dx. For that, what we do? Differentiating. See equation number 1. This is second equation, and this is the form of cycloid. Okay, circle type of, a part of a circle or circle type of figure. Cycloid is known as. So differentiating first and second with respect to the parameter. With respect to the parameter t, in this case parameter is t, so we get what is dx dt. First question, dx dt here with respect to t we are differentiating. This is a into 1 minus of sin t is cos t. Differentiation of sin t is positive cos t. Okay. Similarly, what is d by dt? D by dt from second part, it is a into 1 is 0 minus sin minus cos t is cos t differentiation in minus sin t, so minus sin is already there, it is positive sin t. It is equal to a sin t. Simple. This is, let me take third equation, and this is the fourth one. Sorry, fourth one. Now, therefore d by dx, as I have already defined, that this is nothing but d by dt oblique dx dt. Let me substitute the values. What is the value of d by dt? This is a sin t. Let me write here a sin t. Now divided by a into 1 minus cos t. Further, it can be resolved if I substitute the value of sin t, as we know that what is sin 2 theta. Since sin 2 theta is equal to 2 sin theta into cos theta, and 1 minus cos theta, cos 2 theta, let me take, equal to 2 sin square theta. But here, if twice is the angle, then the angle becomes single. But in this case, single angle is already there. It will be twice a sin t by 2 into cos t by 2. Angle will be halved. Similarly, in the denominator, this is a into 2 into sin square t by 2. 2a cancelled out. 1 sin is cancelled out. So it is nothing but cos t upon sin t by 2. It is not cot t by 2. This cot of t by 2. Cot of t by 2 positive value is left over. This is value of d by dx. So what do we get here? Let me write here. It is nothing but cot t by 2. 1.2 into t. Okay, so from this, d by dx is value cot of 1.2t. Now let me find the values of x and y for different values of parameter t. So substituting different values for different values of parameter t. Now this is in angles here. D by dt is in angles, so we will substitute some angle values. Okay, so let me think about those angle values. What we have to think about. So for different values of parameter t, okay, we have to obtain the values of x, y, and d by dx. For that, let me make the table. Now this is the table. Let me take some values here. Here let me take t. First t, we will substitute the value of t here. Then we will calculate value of x, then y, and then finally d by dx. Now because this is in angles here, let me take some values here. Let me write them in column wise. 1, 2, 3, and 4. And here are the different values. What are these values? Let me just find out some of the values here. Okay, after that, values. So, what angles should be selected? Okay, so what angles should be selected? So, these angles are, let me take 0. First angle t equal to 0, what is the value? Then pi by 2. Then pi, 3 pi by 2, middle values, and then 2 pi. Up to 2 pi, let me take the values. Okay, even after that also we can further go, and the similar shape will be found out of the curve. Okay, We have started from 0, 0 and pi by 2, then pi, 3 pi by 2 and 2 pi. What are the different values for this? So let me solve for x. If I put, this is value of x here. If I put here 0, t0, sin 0, 0, so this 0 into 0, something 0. So x is 0 here. From this y, a, this is 1, minus cos 0 is 1, positive 1. So this is 1 minus 1, 0, 0 into something, this is also 0. So y is 0, cos 0. Now dy dx is this. So this is 0, t0. t0 means cos 0 upon sin 0. Cos 0 is 1, but sin 0 is 0. That means 1 upon 0 is infinity. So this is infinity here, positive infinity. So dy dx is infinite value. It will be the infinite value because it is cos 0 upon sin 0, because for 0, so 0 upon something is infinity, so this value dy dx is infinity. Now pi by 2. Here x is pi by 2, so this is a into pi by 2 minus, it is 1 because sin pi by 2 is 1. Sin pi by 2, so a into pi by 2 minus 1 here. Okay, let me find out the value of x for all the values. And for pi it is a pi, sin pi is 0, it is a pi, a into pi. What is 3 pi by 2? Now 3 pi by 2, this one is, it is 3 pi by 2, that means negative value of sin pi by 2. Sin pi by 2 is 1, so this is minus 1, it will be plus 1. So therefore a into t is 3 pi by 2, this is plus 1, value of x here, it is plus 1 here. Okay, then 2 pi, at 2 pi, a into 2 pi, but sin 2 pi is 0, so it is twice a pi. Twice a pi. In case of x, we have calculated up to all the angles. Okay, now let me talk about y here. What about y at pi by 2? Sin cos pi by 2 is 0, it is a into 1, that means a only. At pi, this cos pi is minus 1, so minus 1 plus 1, this is 2a, this is twice of a. Value of y is twice a here at pi. Okay. Then at 3 pi by 2, cos 3 pi by 2 is 0. Even if it is positive or negative, doesn't matter, but it is 0. So it is a into 1, again a. Cos 3 pi by 2 is 0. It is a again, 0 to a. Then at 2 pi, okay, so cos 2 pi is plus 1, so 1 minus 1 is 0, it is 0 here. Okay, so the same value, 0, a, twice a, in between, and then a, then 0. This is the value of y. Now let me talk about dy dx, okay, for different values. Now for pi by 2, it is now pi by 4, because it is t by 2 already, it will be pi by 4. Okay, so it is pi by 2, so pi by 4 is 1, positive 1 here, plus 1 value of this. And then at pi, it is pi by 2. Pi by 2 is, what is cos pi by 2 upon sin pi by 2. It is 0 here. Cos pi by 2 is 0, because it is pi only, so pi by 2, cos pi by 2 upon sin pi by 2, cos pi by 2 is 0, upon sin pi by 2 is 1, so 0 upon something 0. Now at 3 pi by 2, is 3 pi by 2, so cos 3 pi by 2, 0, divided by sin 3 pi by 2, okay, minus 1, but it is again 0, 0 here. Okay, and then at 2 pi, cos 2 pi is 1, divided by sin 2 pi is 0, 1.0 infinity, this is again infinity. Now, so these are the values of, the variable t, and the different values of, is it something mistake has happened? Let me check it. So at 3 pi by 2, it says it is minus 1. At 3 pi by 2, dy dx is 3 pi by 2. Okay, it is 3 pi by 4 then, I'm sorry. I talked about this. This is 3 pi by 2. If I take, then this is 3 pi by 4. Okay, so it will be minus 1 then. And for this is minus, so this is again 2 pi by 2, that means pi only. So cos pi upon sin pi, it is minus infinity. Minus 1.0 means minus infinity. Sorry, so this is not, I just forgot about 1.2 is also there. Okay, this is the value. Infinity, 1, 0, minus 1 and minus infinity. Alright, these are the values of dy dx. Now, in case of y, we have taken the same value a0, 0a, twice a0, alright, 0a into 1.2 pi minus 1, a pi, and then a into 3 pi by 2 plus 1 and 2a pi. Okay, these are the values. Now they are to be plotted in the form of a curve. So what kind of curve it can be? Now let me start from 0. If I trace a curve for these values, let me trace that curve. What kind of that curve will be? So BC here, let me take 0 to 2 pi, the angles. If I take, okay, here this is x-axis, this is y-axis, y-dash axis, x-axis, x-dash, this is O, and this is x-dash axis. If I start from 0, at 0, y0, x0, this is the first point here. Then at t equal to pi by 2, if parameter t we take pi by 2, then a is a into pi by 2 minus 1, okay, y is a. So y is a, suppose this value is a pi by 2 minus 1 at this point, so a value is here. Because at this point, let me divide this point, first point, second point, this is pi by 2, this is pi, at pi it is 2, at middle point let me take pi here, and this is pi, at 2 pi, angle if I take, and this is 3 pi by 2, and this is 2 pi, let me take, up to these points. So at this, y is 0, is the point, and at this one, it is 1 here, so 45 degree angle, that will be, we take at this point, so tangent will be 45 degree making angle, and sorry, pi by 2, here it is pi, at pi by 2, we have taken pi by 2 also, I'm sorry, this is pi and pi by 2 also. Let me take, this is, oh, I'm taking this is pi here, sorry. What I'm doing here, this is pi by 2. I've written pi 2 times, I'm sorry. Pi by 2, pi, 3 pi by 2 and 2 pi. This is 0. Okay, so at 0, okay, y is 1, x is 0 also. And at this pi by 2 angle, I'm just thinking about these values. Okay, these values of, here we have to think about x equal to a, x equal to 0, and this is pi by a into pi by 2 minus 1. And this is a into pi, value of x. This is a into pi, and this is 3a into 3 pi by 2, sorry, a into 3, this is value of x here, 3 pi by 2 plus 1. And here it is twice a pi, twice a into pi, twice a into pi, value of x up to this point. Okay, now the angles will be here on the curve. Okay, so this will be at this is the highest point 2a. At pi, the value of this is 2a, but value of pi is 2a. Okay, so at the value of a is this is 2a. Let me draw this point at pi. X is a pi and y is 2a. So this is a pi and 2a. The point here, this point, at this point, and at this point, the similar type of values. Okay, so this is the value. So this is the curve here. This is a curve we have drawn here. This is a into value of x is a into 3 pi by 2 plus 1, and y is a. Here it is 2a pi value of x, and this is 0. Y is 0 here, and here it is 0 0 as we have seen. Okay, and at this point this is a into pi by 2 minus 1, a into pi by 2, this one a into pi by 2 minus 1, and y is a. So this point is there. Okay, so in this way the curve is of this kind. This is cycloid. Okay, the 12th question we have drawn here. Question number 12 is of this shape. Okay, the shape of the curve is this. Now if we draw, after this, if we go beyond 2 pi, then the same kind of curve will be repeated. But here also, if we go beyond the 0, same kind of curve will be repeated. Okay, for this beyond y-axis, the same kind of curve here will be repeated. Okay, so this is same shape of the curve again after 2 pi and beyond 0 to minus 2 pi or something. Okay, beyond this. So this is what we have to do. So question number 12 is drawn in this way. This is a cycloid shape of cycloid. Okay, so this is known as cycloid. Now question number 13, let me take. Now question 13, let me check what is the question number 13. Question 13 or 13th question. Question 13. Question number 13 or 13th question, what is it said? Let me check it. Question number 13. Okay, so 13th question, which is something about same cycloid type of question. And all these questions are based on second method. Second method means the method of finding d by dx. Let me take 13th question. Question 13, they trace the curve x equal to this, y equal to this. Again cycloid. Okay, so let me take question number 13. Here the curve is parametric equations are here. The parametric equations are x equal to a into t plus sin t. It is t plus sin t. T plus sin t, and y is equal to a into 1 minus cos t. The same, but here it was minus sign, only this is a different plus sign. Okay, and this is a same value 1 minus cos t. This value is 1 minus cos t here, cycloid, in 13th question. Here it was minus sign, undoubtedly. Okay, let me think about this. What kind of this question will be? Okay, so applying the same method, applying the second method, finding d by dx. This is the second method. So differentiating first and second, here it is first equation, it is the second equation. Differentiating first and the second with respect to the parameter. Here again the parameter is t. So we get what we get. This is dx dt is equal to a into 1 plus cos t. Sorry, sin t is differentiated as cos t. It is cos t. Okay, first question. Then dy dt will be how much? And dy dt is, here it is. This is a into Again, minus cos t. Cos t is differentiated with minus sin t, minus plus, so it is positive sin t. This means a into sin t. This is a into sin t. D by dx is a sin t. This is a plus 1. So therefore, d by dx, which we know, is given by d by dt divided by dx dt. So what are the values? Now d by dx is this a sin t divided by a into 1 plus cos t. So this will be equal to how much? Twice a sin t by 2 into cos t by 2. Okay, divided by a into this is 2 cos square t by 2. Why? Since from trigonometric identity we know that sin 2 theta is equal to 2 sin theta into cos theta and 1 plus cos 2 theta is equal to 2 cos square theta. But here we have single angle. It was sin theta, which one is sin t here. So sin t means sin 2 theta is 2 sin theta cos theta, but here it is sin t. So it will be sin 2 sin t by 2 cos t by 2. This is sin t by 2 cos t by 2, or half of t. Similarly, in the denominator we have 1 plus cos 2 theta, not 2 theta, but 1 plus cos t. The angle is single. This value will be okay. If it is twice, the angle is single. If it is single, then it will be halved. So the angle is 2 cos square t by 2. If it is minus sign, then it is 2 sin square. Right? These are the trigonometric identities which we have applied number of times. So this is not to be okay. So much discussed about. Now let me cancel out 2 cancel out, a cancel out, 1 cos cancel out. This one, it is nothing but tan 1 upon 2t. Okay, again the angle is this much. So d by dx finally is obtained as tan of t. So tan of t we have obtained. Okay, so now let me find the different values of the variable x and y and this d by dx for the parameter t. Substituting different values for parameter t. So we will get, sorry for this, okay. So now for different values of parameter t, the values of x, y and d by dx are grouped as follows. Grouped or calculated, we have put them into a group. So I'm talking about grouped. They are grouped in this table. Let me take what are the different values. So if I take here t, this is t first, then x, then y, then dy dx finally. Okay, so let me talk about them. Okay, so these are the, we'll take some values here. If I start from minus pi up to plus pi, okay, so it is minus pi by 2, then 0 plus pi by 2 and pi. Okay, so for these values, if I take with 2 negative values, then 0, and this is positive value. Minus pi and minus pi by 2, 0 and pi by 2 positive, and then pi, minus pi to plus pi. Let me find out different values here. Again, values of x here, this is minus pi, but sin pi, even if negative positive, it is 0. So it is 0. So minus sin pi is 0. This one, sin pi is 0. But this is minus a pi. Minus a into pi. X is minus a pi. Let me first calculate what is the minus for value of x. And then at minus pi by 2, this is minus pi by 2. it is minus pi by 2. Sine minus pi by 2 is minus 1. So minus sign will be out. Minus a into pi by 2 plus 1. Minus a into pi by 2 plus 1. Why? Because if I put minus pi by 2, it is negative. This is also negative because sine minus theta is minus sine theta. But sine pi by 2 is minus 1. Sorry, is plus 1. But minus sign is also minus 1. So minus sign we have taken common, minus a into pi plus 1. At 0, it is 0, 0. It is a into 0, 0. Then at pi by 2 positive value, this is a into pi by 2 plus 1. This is positive, this is negative value. Now, at pi, sin pi, this is pi 0, a pi positive. Here a pi minus was there. Okay, so these are the values of x. Let me find out values of y. So at values of y for minus pi, this is cos pi. Even if it is minus pi plus pi, it doesn't matter, because cos minus theta is positive cos theta, but cos pi is minus 1. So this minus 1 and this minus sign will be positive, so it is 2a. 2a here at minus pi. Y is 2a positive. Why? Because cos minus pi is cos pi positive. But cos pi is minus 1, so minus 1 plus, so plus 1 plus 1, 2. It is 2a. Okay. At pi by 2, minus pi by 2, cos minus pi by 2 is 0. Cos pi by 2 is 0. Okay, so it is 0, but a into 1 is a positive. It is a here. Then at 0, okay, so cos 0 is 1, so 1 minus 1 is 0, so 0 into 0 is 0. At 0, this value is also 0. Then at pi by 2, a into 1 minus cos pi by 2 is 0, it is a only, positive. At pi, positive pi, it is minus 1 plus 1, this is 2a. At 2a, these two values are there. At pi, it is cos pi is minus 1. Okay, so y is 2a, the positive value. No problem at all. This is the value. At 0, it is 0. If I take 0 at the origin, because 0, 0 is there, and then half shape of the curve will be beyond 0 and after 0, means positive direction of x-axis and negative direction of x-axis. The y-axis will be the axis of symmetry here. Alright, so let me take dy dx now. Dy dx is tan pi, tan t.